In this video, I'll be going over the tangent and cotangent graphs. So here is the parent function for the tangent graph. What we notice is that these graphs are always increasing, and then we have a series of asymptotes. And those asymptotes occur whenever tangent is undefined. So if you think about the unit circle, since tangent is the ratio of sine of x over cosine of x, that ratio will be undefined whenever cosine is equal to 0. And cosine is equal to 0 at these points here. So this is 0, 1, and this is 0, negative 1. That angle up here is pi over 2. Down here is negative pi over 2. And so that corresponds to these asymptotes on the tangent graph. And we could keep going around the circle, and so every time we hit one of those points, we have an asymptote. So those are the key things to remember. And then the main difference with one of the differences between tangent, cotangent, and the other trig functions is that the period length is pi, not 2 pi. So to find the period length, we're going to do pi over b rather than 2 pi over b. Okay, looking at the parent for cotangent, these graphs decrease, and notice that the asymptotes are not in the same positions as the tangent graph. But again, cotangent, the asymptotes are going to appear wherever cotangent is undefined. Remember, cotangent is cosine of x over sine of x. So that ratio will be undefined whenever sine is equal to 0. And those occur here and here. So this is 1, 0. This is negative 1, 0. So this is 0, pi, if I keep going around, 2 pi, 3 pi, 4 pi, etc. So all of those integer values of pi are when we have an asymptote. And again, just like tangent, the period length is going to be pi, not 2 pi. All right, so let's go through the steps on how we graph these. To graph a function, either a tangent or a cotangent graph, we follow these steps. One thing to notice is that the standard form of the equation is just like what we saw for sine and cosine and secant and cosecant. We still have those same a, b, c, d constant values in there. So writing the equation in standard form, that's what this is. Find the period and any vertical and horizontal shifts. So the period length for both tangent and cotangent is pi over b. The vertical shift corresponds to the d value, and the horizontal shift corresponds to the c value. There's no amplitude for a cotangent or tangent graph. The only thing that A is doing is if it's negative, it's going to be a vertical reflection. And then whatever value that is a vertical shift, but we're not going to focus very much on that when we're doing the graphs. All right, step 3, determine where the graph crosses the horizontal axis and where the asymptotes are located. So the period for a tangent graph, let's see. What I use is I say it straddles 0. Hang on. How do I want to say this? What am I wanting to fill in here? The period for a tangent graph. Straddles 0 with asymptotes above and below the x-intercept point. The period for a cotangent graph begins at 0 with asymptotes at 0 and pi. And this will make more sense when we look at an example. But the key thing here is that the tangent graph, it straddles 0 and cotangent begins at 0. And so what I mean here is looking at this graph here, notice this initial piece of the graph, half of that is above 0, half of it's below 0. That's the only trig function graph that is like that. Only parent function graph, I should say, because if it's shifted, that changes everything. But so tangent is the only parent function that some of it is above 0, some is below 0. Cotangent, notice that first graph starts at 0, so it doesn't cross the y-axis. And then determine the equation of the asymptote lines. It's going to be the same formula as we saw for secant and cosecant. It's going to be y equals any asymptote plus k times the distance between asymptotes. Okay, and then we apply any horizontal and vertical shifts, and then sketch a smooth curve through the points we found. All right, so let's look at a graph of it for each of these. Follow the steps from above. Graph 1 period. Find the equations for all asymptotes. Writing this in standard form. Whoops. The a value is 1, so I'll write 1 tangent. The b value is also 1. I can factor that out. Plus 1. Okay, so the period length is, remember, pi over b. So it's pi over 1, which is pi. So when I do the number line here, all we need to do is graph the beginning, middle, and end. We don't need to find the quarter points here. So the beginning, I'm going to take that period. It's pi. Half of that period is above 0. Half of it's below 0. So it's negative pi over 2 to pi over 2 is this period length we're going to look at. And then the horizontal shift says we're going to move right pi over 4 units. So what I need to do is I need to add pi over 4 to each of these. So the new number line, well, 0 plus pi over 4 is pi over 4. Getting a common denominator, we'll have negative 2 pi over 4 and then positive 2 pi over 4. So adding those together, negative 2 pi over 4 plus pi over 4 is negative pi over 4. 2 pi over 4 plus pi over 4 is 3 pi over 4. So those are the key values I'm going to plot on my graph. And I'll just say, so negative pi over 4, pi over 4, and then 3 pi over 4. Okay, so the asymptotes for the tangent graph are always at the beginning and the middle. I'm sorry, at the beginning and the end of the period. And it's the same for cotangent. Okay, and then we have a vertical shift of up 1. Okay, so the original tangent graph, the tangent graph is always increasing. So the original tangent graph would be increasing and going through pi over 4. But because there's a vertical shift of 1, I'll put it up here, the graph is going to hit at pi over 4 and 1. And then I just kind of draw a curve through that point towards the asymptotes. I wanted to come up with a second period. Well, all I need to do is add a new period length. 1, 2, 3, 4, 5, 6. Kind of running out of space here, but I'm going to have an asymptote over here, and that is 7 pi over 4. That's 7 pi over 4 because it's just pi units greater than 3 pi over 4. And then halfway between those is 5 pi over 4. And then the graph just repeats itself. It passes through that. And I could keep going. All right, and so the instructions say find the equation of the asymptotes. Well, the asymptotes are going to be y equals, pick any asymptote. How about pi over 4 plus k times the distance in between asymptotes. Oh, sorry, pi over 4 is not an asymptote. Let's try that again. We'll do 3 pi over 4 plus the distance in between asymptotes. So the distance in between these asymptotes. Well, 7 pi over 4 minus 3 pi over 4 is 4 pi over 4, which is just pi. So this is k times pi is the formula that'll get us any of the asymptotes. All right, and then let's look at a cotangent graph. Writing this into standard form, y equals 1/3 cotangent. I need to factor out that 4. I'm left with x minus 2 pi over 4, which is the same as pi over 2. So we'll write pi over 2 plus 0. The period length is pi over b, so pi over 4. The horizontal shift, we're going to go right pi over 2 units. So mapping this out, when I map out the cotangent graph, I do start at 0 and I end at pi over 4. So that's what's different between tangent. Tangent, I do half above and below 0. And then the midpoint of that is pi over 4 divided by 2, which is the same as pi over 4 times 1/2, so pi over 8. And then what I need to do is I need to add pi over 2 to each of these. Okay, and so what we're going to have here, this is pi over 2. Pi over 8 plus pi over 2. Pi over 2 is the same as 4 pi over 8. So that's 9 pi over 8. And then pi over 2, getting a common denominator, 2 pi over 4. I'm going to get 3 pi over 4. Okay, so this is where the asymptotes are. And then there's no vertical shift, so I'm going to cross right there in the middle. And then the cotangent graph is a decreasing graph. So let's put it on the grid here. Pi over 2, 9 pi over 8, 3 pi over 4. Asymptotes are here and here. Then this graph is decreasing and it goes through that middle value. And there you have it. One thing to notice is this 1/3 is going to vertically stretch that, so it's going to make that graph steeper than if that leading coefficient, it's going to compress it. So if it's hard to do a comparison on a graph like this when I'm just doing one curve, but if the leading coefficient was 1 and it looked like this, if it's compressed, it's going to be kind of even flatter like that. That's an exaggeration, but that's kind of that's what that 1/3 coefficient would do to the graph. Okay, and then lastly, the asymptote is going to be y equals, pick any asymptote, pi over 2 plus k times the distance between asymptotes. So I'm going to say 3 pi over 4 minus pi over 2. Pi over 2 is the same as 2 pi over 4. So this is pi over 4 is the distance in between. So we'd say pi over 4 here is the formula to get us any asymptote.